Okay, first of all we will learn about the chapter triangles. Okay, so here we have the first thing we have to learn here is similarity of triangle. Similarity of triangles. There are two basic rules to find out how the triangles are similar. Say the first one is two triangles are similar if number one, their corresponding angles are equal. Okay, and the second one is if their corresponding sides are in the same ratio. Okay, now these two things we will understand here. Say let these two be the triangles, this one and this one. This is the bigger triangle, this is a smaller triangle. Now in these two triangles we are given here their corresponding angles are equal. So in these two triangles we can see that all the corresponding angles of these triangles are equal. Now look here, this angle is equal to this angle is equal to this one is equal to this one. Okay, again, if this angle is something x degree, this one y degree, this one z degree, so this angle also must be x degree, this one y degree, and this one z degree. Now let's name these two triangles ABC, PQR. Okay, now let's come to the second point. Their corresponding sides are in the same ratio. Here what we can write, ratio AC by AB is equal to PR by PQ. We can write this one, AC by AB, that means this side, this side, this side, and this side. AC by AB equals to PR by PQ. If these conditions are satisfied, the angles equal, the ratios are equal, then we can say that these two triangles are similar, this one and this one. Okay, now let's move on to the theorem number 1. In theorem number 1 it is given as theorem 1. What does the theorem number 1 say? It says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. What is the theorem saying? The theorem is saying that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided into in the same ratio. Okay, we will draw the figure here. Say this one is the triangle and we name it A, B and C, and let this one be the parallel line drawn joining the two sides AB and AC. We will name it D and E. That means DE is parallel to the side BC. We will write here DE is parallel to BC for better information. Now, according to the theorem, we need to prove. We have to prove what? We have to prove the ratio. What is the what ratio? AD by DB. We have to prove AD by DB must be equal to AE by EC. AE by EC. So we need to prove this relation. Now in order to prove this relation, we have to make some constructions right here. Okay, say we have to join B and E. Again we have to join D and C just to make the different triangles. Say after joining these two, we get the triangle DEB and DEC, like this type of triangles. Again, in the triangle ADE, we need to draw two altitudes. Say we will draw one altitude from E on AD. Okay, we have to draw one altitude. Altitude means a line perpendicular to the other side. Say this is 90 degree. So E, we name it, say its name is N. EN is perpendicular to AD, or we can say that EN is altitude over AD. Again we have to draw another altitude from D upon AE. So this one is the another altitude. This is also 90 degree. Now the proof starts here. Before starting the proof, one thing is to remind that we'll use the area formula of triangle here. The area of triangle, as we know, area of triangle is equal to half of base into height, or instead of height we can write altitude. Which one is flexible for you? Apply that. Okay, here. Now first of all we will consider the area of this triangle ADE. Okay, so what will be the area of ADE? As we have here, area is equal to half into base into height. That means here we, in this triangle, first of all we will consider AD be the base and EN be the height. So area of ADE is equal to half of base is AD into altitude is EN. Okay, now move on to another triangle. Now we will move to this triangle BDE. This BDE. So what will be the area of this triangle BDE? Area of triangle BDE. Again from the formula, half into base. Now look, in this triangle BDE, we'll consider this BD or DB to be the base. Let's for the flexible here, we have written DB, we will write DB here. So the base will be DB and the altitude will be, or the perpendicular will be EN. Again here also it was EN, and for this triangle also EN will be the perpendicular. So we can write here base DB into perpendicular or height EN. Again, for this triangle we have got two altitudes here. We have taken out the area of one altitude. Again we can take out the area of this triangle with this another altitude. Okay, so how we will write this? AR, area of ADE. Now this time we will take AE to be the base. Previously we have taken AD to be the base. Now this time we will take AE to be the base. Okay, so AE, the altitude will be, well, I name it DM. DM. Again, similarly for this triangle DEC, area DEC, half into, now in this triangle DEC we will consider this EC. Okay, EC to be the base, EC, and altitude will be again DM, half of EC into DM. Now here we will have to do some divisions right here. Say we will divide this area by this area. Again we will divide this area by this area. Let's see what happens. Now we divide this area by this area. Area ADE divided by area BDE. Okay. Now what will become? This will come as numerator AD into EN, and this will come as denominator half into dV into EN. Okay, this EN will cancel out, half will cancel out. What will remain? AD by dV. Again we can write this one something like this. We'll keep this area left hand side and we will move this area to the right hand side. Say area ADE is equal to AD by dV, this one, and when this will come this side, it will be multiplied, it will become multiplied with this fraction, so this will be area BDE. Now number it as number 1. Okay, now next we will move again to the division of these two equations. Now we will divide this one by this, area of ADE divided by area of DEC, and in this case this one will be the numerator, half of AE into DM, and this one will be the denominator, half of EC into DM. DM will cancel out, half will cancel out. What will remain? AE by EC. Again same thing we will do. We'll keep this area in left hand side and move this area to the right hand side. It will become area ADE equal to AE by EC, area DEC. Okay, this one number 2. Now from number 1 and number 2, this area are equal, area ADE, area ADE, so therefore this thing will be equal to this thing, so we can write it like this, AD by dV, area BDE will be equal to this one, AE by EC, area DEC. Yes. Now one thing we have to do here, now this area BDE and area DEC, we have to make these two area equal. How to make equal? We can see from the diagram itself, these two triangles BDE and triangle DEC, these two triangles lies on the same base. Okay, same base DE, and these two triangles are within the, or we can say in between these two parallel lines. Now just imagine, say if we draw one altitude like this 90 degree here, okay, or say like this. So what will become, will for both these two triangles will have the same base and same altitude to find out the area of these two triangles. So ultimately these two triangles will become the area of these two triangles will become equal. So what we can write here, so there are some statements you have to write in bracket within here, so I am doing just rough work. Okay, after examining this we get that these two areas are equal. Now if these two areas are equal, then these two areas will cancel out, and what will remain at last is AD by DB equals to AE by EC. AD by DB, AE by EC. This is the what we were asked to prove in the theorem AD by DB, AE by EC. So hence this theorem is proved. Okay. Now move on to the second theorem. Now look in this book. The second theorem is given as, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, that means this theorem is just exactly the opposite of this theorem. But in your book, the derivation or the proof is not given properly. Okay, so with this we can make our mind that this derivation is not so important, because if you want to derive this theorem, you have to go in the backward direction of this theorem. Okay, you have to find the area, or you have to match the equation like this. So you have to go in opposite direction of this theorem, then only you can prove. So as the theorem is not given properly in your book, or the proof is not properly stated in your book, I think this theorem is not to come in your exam. But you have to apply this theorem in some of the questions that will be provided in your exercise. So this theorem is very important. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. You have to apply this theorem. Okay, that's all for today. Tomorrow I will be teaching you the examples right here. Okay, example number 1, example number 2, and example number 3. After that we will go on to the exercise. Today you practice this theorem, make it thorough, make it memorize, or if you make it clear understanding in your mind, that it will be much better. Try it for 3-4 times. Okay, make it clear understanding about how the altitudes are drawn, how many altitudes are drawn, what is the purpose of the construction here. Say BE and DC are joined here, so why it is necessary, why we need to be why these things are to be constructed in order to prove this theorem. Okay, so make it thorough. Okay, see you tomorrow.